Won't take up the full hour and 15 minutes anyway, so we can give people another few minutes to get here.
Okay. I know there are.
I know some speakers run over, and I don't know.
All getting settled in. Let's quieten up, please. Thank you. So hey everyone, welcome. This is Douglas Mallette talk. Mallette, right? Mallette. Okay, Mallette. So who here ever dreamed of becoming an astronaut? Raise your hands. Quite a few of you. Okay, for those who didn't raise your hands, what did you dream of? You. Okay, sure, go. Chef and then a vet. So what are you doing right now? Surprise! Yeah? Okay. Well, I know I dreamed of becoming an astronaut, and I never quite made it that far. Hey, I'm a CS major. I switched out of CS into linguistics, and now I'm kind of leaning on going back into CS. So even my life story is kind of incomplete. So I guess I want to say that space still plays a very important role, even though we kind of just forgot about it. 1960s, we went to space, and then through the 1980s, it was just like, yeah, we're in space, and now it's just like, hey, space. We go up there once in a while, and now we're maybe never going to go back up there ever again because we don't have enough money to fund the program. But Douglas Mallette, he loves space, clearly, and he wants to tell you why going back up there will determine the rise or fall of humanity.
Testing, 1, 2. Am I on? Are we working? Good, fantastic. Okay. So just to give you a little background on myself, I am a systems engineer with the Space Shuttle program. I work in Houston, Texas with the Boeing Corporation as one of the subcontracted representatives that work on the Space Shuttle program. What we do is we basically manage all of the technical drawings. So think of anything AutoCAD related that would show what the space shuttle is going to look like in the payload bay. We manage the configuration. I'm in the department called Configuration Management. Now, some of you might even be aware of configuration management from the software side of things. I do hardware configuration management, which kind of sucks because when the space shuttle goes away, I'm job hunting, and all the damn CM jobs are for software stuff, and I'm not a software guy. But there's not a whole lot of hardware CM that I can find. But what we do is we make sure that the drawings match up with what the mission is going to be. I'm actually assigned to OV-105, which is Endeavour. My bird launches February 24th, and then Discovery launches about in April, but we're still playing with the date of that a little bit. And we may get another Atlantis flight around June. Congress gets to determine that one, so let's not hold our breath. So that's what I do with space exploration now, but that's not all I do with regards to the space industry. I did write a space advocacy book, and I have a couple of them up here if anybody's interested at the end. So what does this book do? The problem with, and as much as I love my comrades, a lot of scientists and engineers don't have the foggiest clue on how to explain the importance of space without going over everybody's heads. I have been blessed, one could say, with the ability to make the complex non-complex. And so I explain in the book why space exploration and development is so important. And so that's kind of one of the things I'm going to talk about today. Why is it important? What does space exploration and development provide us? And I'm not just talking satellites for communication, although that is obviously a huge part of it. But other technologies that, if you don't challenge yourself in an extreme way, going to the moon, going to Mars, going to an asteroid, then you're never going to accidentally invent something that could be used back here on Earth to help humanity or to help the mission. So you always have to raise that bar. If we stop raising that bar, we are going to roadblock ourselves. So the first thing we have to look at is, why do we explore in the first place? What is it about the human creature that causes us to want to go to that over that hill and hope that whatever's on the other side of that hill doesn't want to eat us. The first step would be curiosity. We just want to know. Ask any mother of a young child how many times she has to tell him or her to get out of the big giant box with cold stuff in it. The refrigerator. Huh? What's in there? And then the milk falls on their head. You know? But the kid wants to know. Or starts playing around the stove. Or goes into the closet. Where did the kid go? I don't know. He's investigating the vacuum cleaner. Don't know how he got in there in the first place. But, so curiosity. What is over there? And through that curiosity, we end up expanding our knowledge base. We start to learn more things about ourselves. We start to learn how we think, how we operate, how the environment reacts to us, and how that environment works in the first place. And it's also a step in social development. You go from the individual caveman to exploring around and finding some friends, to, well, let's make a village, to, I want to move to the suburbs. This is too congested. But that's part of the exploration development, is it not? You end up finding circles and groups and developing communities, and that is part of the process. But one of the best reasons of all, to me anyway, and most people do agree with this, is adventure and excitement. And yes, I did put Indiana Jones on the slide. I guarantee you, and I know because I talked to them before, if you ask any astronauts, I'm on a bowling league with the pilot of my shuttle that's getting ready to take off. So they will tell you it is one hell of a ride. And it is something that they will never, ever forget. And it is fun, it is exhilarating, it is exciting, it is dangerous. But it is also important what they do. And they know that. They're very fortunate to have the credentials, to have the education, to have the ability to do these amazing things in space. And we are now getting to the point with the development of commercial space with your Virgin Galactics and SpaceX and X-Corp, to where we are now starting to come over the hump to let other people, average people, regular everyday people, get into space. Yes, the ticket price is going to be $200,000 to suborbit. But if you look back in time, the original aircraft across the Atlantic was expensive too, relative to the economics of the time. So it will come down. But what can space help with? What are some of the things that space has given us that, unfortunately, a lot of people have forgotten about? Space seems to be on the back burner of a lot of people's minds, but they don't realize that space is on the front burner of virtually every single thing they do every single day. But it doesn't register because it's not. The media is more interested in the most recent Paris Hilton or Lindsay Lohan escapade than they are about covering a 14-day shuttle mission and all of the special stuff that's going on in space and the technologies that end up filtering down to help us every day in our lives. So one of the things to talk about would be education. If you're going to do something as complex as space exploration and development, you're going to need a solid foundation of an education in order to accomplish that. So whether it's a technical trade, bachelor's, master's, or a PhD, there are different levels of education that are beneficial in space exploration and development, in the space industry as a whole. So what would the educational passion be? What would the education drive be for this kid or those kids if they knew without a doubt, that that is where they could be going? It's one thing to think, well, maybe we might get a moon base one day or we might get a Mars base. But if we actually had a real solid push to get this done, you would see a lot of imagination and a lot of passion come out towards getting the educations to make that happen. Turning sci-fi into sci-fact, which is basically what we do, right? We imagine this ludicrous stuff. We're going to go orbit the planet. We're going to go to the moon. And then we do it. And we end up inventing a whole host of technologies to get it done. Technologies that end up helping the medical field, end up helping local transportation, end up helping advanced computing. So it's not just building a big fat rocket, which is fun. but it's also about all the other things you end up getting out of it, such as the technology. So what I'm going to talk about right now are some of the technologies that space exploration, the space industry, either has a hand in, had a hand in, or influenced in some way or another. And I'll try to put stories to these as well. Memory foam mattress, right? Everybody knows that. That seems to be like that and Tang. Did you know that the space industry had a large part in developing plasma televisions? Did you ever thought of that one? It's actually a zapper. It'll get rid of the acne. Hierarchical segmentation enhances diagnostic imaging. In other words, brain scans. Largely developed because of the radiation testing and whatnot on how to study the skins of spacecraft in the radiation environment of space. Ends up developing technologies that help scan people's heads to diagnose and help the medical industry. There's one for any artists. Corrosive gas restores artwork and promises a myriad of applications. That's the thing that's beautiful about the space industry. You might have this one target. We want to do this. By the time you reach that target, you found out that you can use that same technology to do that, and to do that, and to do that. And the next thing you know, you've got a broccoli tree of things that come off of what the original mission was. Additive transforms paint into insulation. Insulated paints. How many of you are familiar with insulated paints? Have you ever heard of it before? Did you even know such a thing existed? Basically, you paint your house and it is the insulation. It's got an insulated part built into it, which is advantageous on spacecraft. Clean water for remote locations. This happens to be a device in the International Space Station that is a fully self-contained water reclamation system. And it basically, let's see, what does it say? Hardware that allows constant supply of clean water for 4 to 6 crew members aboard the ISS. And it reclaims wastewater, including water obtained from the space shuttle's fuel cells, crew member urine, etc., showers, hand wash, oral hygiene water, basically all of that. Because when you're in space, it's not like you can just run to Walmart and reload. It's not quite that easy. And even more so if you're on the moon or if you're on Mars. So you've got to be able, you have to develop systems that are as sustainable as possible. That seems to be the catchword these days, right? Sustainability, right? That's in the news. Green, clean, sustainable for the earth, for our environment, for combating global warming, for this, that, and the other thing. Sustainable. Because we only have one planet. Okay? If we keep going at the rate we're going, we're going to be out of a home real fast. And unless you happen to have one sitting in the back, last time I checked, we don't have an extra one. You know, this is it. So we have to do things in a better way to where we can still live good qualities of life, but we can also use our technological prowess to be sustainable. So sustainability in space increases sustainability on Earth. The things that you have to invent to be sustainable on Mars can and usually are applicable right back on Earth. And I'm going to go through some of those. What are some of the things, let's look at the perspective of an astronaut going to, say, a moon base. What are the biological necessities of life for that, the human creature to exist? Air, food, water, sleep, medical care. Those are pretty much the primary 5. Sleep is highly regulated in space. I mean, they have to force it anyway because you're orbiting a planet. Well, the ISS orbits once every 90 minutes. So you've got a sunrise and a sunset going off a lot more than here. So you got to force yourself. They have to sleep shift cycle and close windows, and basically they have to fake it. Well, they do a pretty good job. The schedule is very, very managed. So what about a quality of life? Something like shelter. Well, now on Earth, you don't necessarily need a shelter to live. I mean, it makes your quality of life better, but it's not a necessity. You could just sleep under the stars and, you know, hope it doesn't rain. Oh, sorry. But if you're on the moon or Mars, there's no atmosphere for you to just lay under. So in this particular case, shelter is both not only a quality of life need, it is a biological need. If you're in a harsh environment, you actually need a shelter to survive. Clothing, education, energy, transportation, communication. The space industry does have an influence in pretty much every single one of these. We're going to go through some of them, just to give you a greater appreciation of what the space industry does. And hopefully, if anybody ever says in the future, why are we spending money on space when we could be doing something else with the cash? Yeah, like what? Going to Starbucks? Do you realize that last year this nation spent just about as much on Starbucks and Dunkin' Donuts as the entire NASA budget? Okay? So that's disturbing. About $18 billion. Abundance. By far the most important word with respect to mankind's ability to live on another world and peacefully on this earth. If you're in space and you do not have an abundance of a need, you have scarcity, you have a problem. Because resupply is not that easy and people can die in that harsh environment. So you need to develop this, where we get back to the sustainability of systems. The sustainability to create the abundance so that the astronauts, the space adventurers, maybe you, or your kids, my daughter, maybe, can explore space safely. So what kind of technology for biological needs can we do that involve abundance for, say, living on Mars, but also can translate back to Earth? So biological needs, air. Well, that's pretty abundant, unless we chop down every single tree on the entire planet. Well, and we need to do a really good job of making sure that the air we have is clean and breathable and whatnot. But if you're here, you have a closed environment, so that's where you have recycling and scrubbing of the air. So you have to invent special filters to help accommodate for any nasties that could be floating around in the air. So what if you're here on a moon base? Well, you can do things a little bit differently. You're still going to need the scrubbing and the recycling of the air, but you've also got water, and you can use electrolysis. Anybody aware of the huge moon water find that was recently in the news because of LCROSS? Anybody familiar with LCROSS? Where we basically flew an SUV into the moon. Pissed off a lot of crazy people. Say, oh my God, we're going to destroy the moon. Why are we bombing the moon? Well, you know, if anybody had half an IQ, they could look at the backside of the moon, which we have pictures of, and it is loaded with pockmarks because the moon is our shield. It gets hit frequently, all the time, by things larger than what we slammed into it. The only difference is we did it on purpose so we could study it. When nature does it, it's kind of, good luck finding out when that's going to happen. So we flew the SUV in, created a poof, and then flew the scientific instruments right behind it, and then it went right into the same hole. Well, yeah, you think, well, that's kind of a waste. Yeah, but the science we got off of that was amazing. We found out that the moon actually has a lot more water on it than we ever thought possible. That water can be used to be water to drink for your systems. Also be split into hydrogen and oxygen, one to breathe, one for fuel. So you could turn the moon base into your orbiting gas station, which would be a lot easier to go to Mars or asteroids or somewhere else if you just had enough fuel on your spacecraft to get up to the moon and then reloaded it and then kicked off from there. Or if you actually did construction on the moon and built just a larger spacecraft that can hold more cargo and hold more stuff. There's a lot of ways. There's an infrastructure issue that you could put into that. So with water, you've got desalinization plants. This is on Earth. Local rain collector facilities, centrifugal centers, systems like I showed that were in the ISS that do water reclamation and clean. And an example of this, there's a publication that NASA does every year called Spinoff, which basically shows all of the spin-off technologies that they either directly invent or work with industry to create. Like portable nanomesh creates safe drinking water. Basically, in effect, it's a glorified water bottle with a screen in it, and you can go to the nastiest puddle in the savannah or in third world nations or something that the giraffes and the hippopotamuses are rolling around in. Grab that, run it through the mesh, push it out, and you have perfectly clean, drinkable water through that mesh. And NASA ended up helping inventing that. That's a lot easier to deal with than to build a big facility. If you could just give everybody, all the villagers who live there, a water bottle, well, they could go to any local area, any watering hole, and be able to get drinking water. That is a good stopgap solution until you can get in there and build an infrastructure with rain collectors and things like that. Food, vertical farms, hydroponic, aquaponic, self-sustaining, solar-powered, fully automated. So if you're on a Mars or a moon base, you can't exactly be Farmer Jim, with a big square acre plot of land and a rake. The soil, one, doesn't work that way. It's not the same as on the Earth. Two, that's a lot of physical labor going into that process alone, and you're on a completely different world. You're not exactly going to behave the same way. It's going to be more challenging. If you can create a building or a system that quite literally does it all on its own and just starts cranking out food out the back door, done by robotics, this is where you guys would come in with computer science and the programming and being able to get the robotics to perform those tasks in lieu of human labor. Because the astronauts are going to be busy doing all the science. They're trying to do other stuff. They don't need to be sustainable living. They need something a little more advanced given the environment that they're in. But now if you think about it, if we can do that, and by the way, this is possible. It already exists. The technology exists for this to occur. It's already been developed for Moon, Mars base, and on spacecraft. But if it exists now for that, why can't we just put it in third world nations? And we can add an added energy element. You can add fuel cells to the system, and you can add wind power to the system. So you can have a building that is a fully automated hydroponic, solar, wind, hybrid, fuel cell powered, off the grid, on its own, drop it in the middle of the Sahara Desert, and it will still crank out food. Because it's completely climate controlled and self-sustaining. You want to fix world hunger? Sleep, we kind of talked about that with the mattresses and whatnot, and the regulation that goes involved. And if you're on a different world, you're not exactly running on Earth cycle. Medical care. Earlier on, actually, the previous gentleman was talking about the needle. I don't know, who was in here for the last talk? All right, talking about that funny robot, the Lego robot trying to, what if it was a needle poking at you? Well, that right there is called Da Vinci. And that's a robotic surgical device. It's an amazing technology. Basically, the doctor sits in there with this 3D glass setup and has his hands on the triggers. And he can manipulate very, very, very fine, precise instruments and do surgery faster, cleaner, better for the patient, much faster recovery time. We're talking on the order of magnitude 3 to 5 times faster than normal. The incisions are much more precise. They get in there, they get what needs to be done, and they get out. You don't have to just look up Da Vinci Medical on YouTube, and you will find all kinds of information on it. It's an amazing medical system. And on the flip side of that, you've got the ISS, which does biological research. The human body doesn't exactly behave the same in orbit, or it would be on the moon or Mars, as it does on the Earth. There are positives and negatives to that, and either one we can learn from. We know that muscles atrophy, that there is a significant biological detriment to being in null G. All right? It's not really 0 G. People say that, but it's not 0. There is gravity there. You're just falling faster than that. So anyway. So if you're in a null G environment, how does your body react? And you can also look at crystalline structures, and you can look at viruses, and you can look at bacteria, and maybe you can develop antidotes, or you could start looking at serious illnesses that are on the Earth, ship versions of it up to space, and see if there's a way you can beat it. And if you can beat it up there, maybe you can beat it down on the Earth. So there's a lot of medical research that goes on the ISS. Things that end up trickling down and benefiting people right here at home. So, technology for quality of life. Let's look at some of these. Shelter. There's a technology in development at the University of Southern California called contour crafting. Basically, I love this technology. It's a self-erecting robot that then automatically builds a house. It can build a 2,000 square foot house in a day, in 24 hours. All right? 2,000 square foot house in 24 hours. Okay? So basically, it's a huge 3D printing machine in a way. It just kind of lays this thing out. You basically and this includes electrical and plumbing. This isn't just building walls. This thing can also plumb and set up the electrical and all that in the house. You really only need Like what do we have in the picture? The cute little picture here, we got one dude at the computer station going, all right, make sure it's not going to break. Another guy going, I'm going to get the coffee. All right? So you've got two guys. How many people does it take to build a house now? All right? A construction crew of what? 20 or 30 people or so? Yeah, it depends on how fast you want to get it done, too, but a typical house. Now, look at how much waste is also involved in that construction process. There is a lot of money blown, resources blown in the traditional method. We've got to kind of start getting away from our traditional passions a little bit and start looking at the smarter, better, cleaner, faster way of doing things. I just want, and this would be significantly important on a moon base or a Mars base, right? Because what if you would want to send the robots first to kind of set up your initial infrastructure. Then the astronauts can show up and kind of fine-tune whatever they need to fine-tune after that. But you don't want to send the astronauts with hammers and shovels and have them build everything from scratch. It's going to be a harsh enough environment as it is. You're going to have a lot of extra supplies to make that happen. If you can do it robotically first and at least set up the initial basic infrastructure, then you've just made the process a lot easier for the human element. Now, think about Haiti and what happened in Haiti with the earthquake. Wouldn't it have been amazing if after that fiasco, after that happened, you cleared off that entire plot of land, dropped 5 or 6 of these machines, and just cut them on, and they went chkunk, 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 and just started building houses one every 24 hours. Actually, you have them in a row. So you have like 4 or 5, so you're doing 5 houses a day. Those people, there are people who still are living in tents in Haiti. And it's been how long now? Imagine if we had this running regularly since then. The whole damn city would have been rebuilt by now. And this is simple, fun little geometry it's showing you. This technology can do much more complex. But it's not in full development yet. And it's not in full development yet because of money. He doesn't have enough yet to do the initial prototyping systems. It's these kinds of innovations that need to be supported by people like us. The ones who want to see, those of us who want to see the future become more than what it is right now, this psychotic mess of doing things the old-fashioned way, when we should be really investing and pushing and promoting and talking to our local TV stations and getting things like this on the news and the humanitarian ways that these technologies can help human beings survive. Who was this morning with Mr. Hart's 3D graphical models, his artwork and things like that? How many times did he talk about using 3D printing to create these really complex things? Same idea with what if you're on the Mars or whatever, and you had, or on the moon, and you effectively, what I affectionately call in my book, I call it moon Crete. If you had just a little bit of lunar dust and a little bit of a chemical mix and you made this moon Crete, you could make stuff, make whatever you need out of this 3D system. You could print it. Or if you had shipped plastics or whatever the case may be, you can make your bowls, you can make spoons, you can make whatever you need there. Instead of having to ship stuff, you just send the raw materials and let these advanced systems make these products for you. Again, another applicable system in a third world environment where they are trying desperately to survive and develop and grow to a 21st century level. These kinds of technologies, if used in a humanitarian, altruistic kind of way, could help them achieve that. Education. I think we're all pretty well versed on how technology helps education. And a lot of that, as far as the space industry is concerned, is pushing the science, engineering, and technology aspect of things you can do with your life. There's also different research going on how to implement education. The gentleman right here, Sugata Mitra, if you looked him up, he's given TED Talks on restructuring the educational paradigm. Right now we have the very Bismarckian system, which is kind of what I have now. The teacher up front and all the little rows of students in the back. And it's not a very dynamic, interactive educational set. Technology helps with that because he uses the internet, global communications. That's where the space comes in, the communication aspect. The satellite communications to basically give information at a moment's notice at the speed of light to people around the world. That's something we've never had before in human history. That's something very important you should think about. You now have access to almost any kind of information that you need at the push of a button. That's makes the world a very small place when you have that potential, which is good. Then you have energy, clean energy, not dirty burning stuff, the caveman way of doing things. I mean, we've harnessed the power of the atom. We understand the electron. This is the age of the electron. Let's use it. So you've got your solar. The space industry definitely had a large part to do with that, with the satellites and everything that needed to be powered in some way. They also, of course, pioneered fuel cell technology. But there's also this one, space-based solar power. It is a serious technology. It's been on the books for decades. Well, basically, you have a satellite up there that collects the raw solar power, converts it into a very safe microwave beam, and blasts it down to a receiving station. You could fly right through it in an airplane or something. Your airplane would be like a Faraday cage, so the microwave beam would hit it and kind of go around it, so people wouldn't be damaged by it. Bird could fly right through it. Probably wouldn't want to sit in it very long, but what's going to really sit in it? It's going to a receiving station that nothing's really going to be on. And so if you did research on space-based solar power, there's no limitation. What's the limit to natural solar, to ground-based solar? Well, one, daytime, nighttime. That's kind of a big one, right? Or clouds, rain, different environmental restrictions that are going to impede the efficiency of that system. Space-based solar power, it is set up in a geosynchronous orbit so that that satellite 24/7, 365 is getting hit by the sun, and it is always beaming energy back. And you can also rotate the satellite so that it can hit multiple receiving stations in a circle, and you can charge battery banks in villages and towns and just kind of rotate it around. So it is a very mobile, covering a large range power system. This is a really good technology, the Bloom box. All right, if you're not familiar with that, I highly recommend you just take a look at it. It's an amazing technology, kind of a part space application, part private industry. NASA does a lot of that partnership with private industry. Wind. People think wind, all they think is big giant windmills going around. I happen to be a huge fan of vertical towers. They're much more efficient. And if you put magnetic bearings in them, you can basically blow on it and it will spin because it doesn't have the same friction resistance of having regular bearings in it. So you have these vertical wind setups, just like these lights. This happens to be a CG graphic display, but it's perfectly conceivable that you could have these magnetically set vanes on these lights, and just the slightest breeze will get it going, and it will keep the lights going at night. Or at least during the day, charge batteries that are at the base, and then the batteries would feed it at night if there's not enough wind. But the wind would be the primary, the batteries would be the backup. Wave. People forget that we can harness energy out of nature. See, there's a lot of clean energy options. We're not looking for one super duper omega source of energy. It's all of these in concert working together based on the geography of where you are. They have one of these in Ireland that's working. Tidal. Tide goes in, tide comes out. They can harness the power of that. Geothermal. Iceland has a lot of geothermal. Depends on where you are. Geothermal is not going to be good in some cases, but then you might be able to use the wind, or use the wave, or use fuel cell. And I'm talking on like individual home levels. Imagine if every single house in, say, Chicago had these systems kind of part of them, so that almost every building was a source, not a sink. So then your big buildings might be able to feed off of all the power, so each house has its own power supply for the entire city. That is a more integrated, interactive, and when you add the computer science bit of communication, all the houses talking to each other, kind of that live, active grid, where everything's kind of shifting energy as needed, then you end up having a much more dynamic and robust energy system in the city that's totally clean and pollutes nothing. Let's go to transportation. What time am I? Okay. So things like this are driven by GPS, which of course is significantly derivative from space exploration and development, getting those satellites up there that can provide the GPS coordinate systems. This is called the ultra transport. Basically, you hop in, you tell it where you want to go, and it takes off and it goes down these little tracks. They actually have this running in England right now at the Heathrow Airport, kind of test running this system as a way to get around the airport. Transportation, electric cars. Now, I just happen to like Tesla because their cars look pretty badass. But, you know, you've got, was it Nissan Leaf that's coming out or has come out already? All right, so electric cars are finally catching on. They're not these little small slow things. There is a electric drag car. I think a guy retrofitted a Datsun or something like that. He blows Mustangs and Corvettes off the line. All right, he is significantly faster than the sports cars that he goes up against in his class, because electric power is instant torque to the tires. There is no lag or delay or anything. It's like you press it, you're gone. And if you have four-wheel power, in other words, if every one of your wheels is its own electric motor, it's called the Skate. It's by GM, the GM Skate. And it's basically just a frame of a car, but inside each wheel is its own motor, and all the fuel cell batteries are inside the frame. It's about yay thick, and that's where all the batteries are. So you can literally put on top of it whatever car look you want. The frame stays the same. I want to drive a pickup truck today, so you put the truck on there, or you put the sports car on there, or the sedan on there. You can kind of set on it whatever you want. It's almost like Lego car, right? But it's electric powered, and each tire has its own motor, so it's more efficient. It draws power directly to each tire. It's not one central unit going to each individual tire. It's a very interesting idea. If you look it up, again, you can YouTube it, GM Skate, and you can see all kinds of information on it. And so you've got electric cars are coming out. And, of course, what does the space industry have to do with this? Well, who do you think really invented a lot of the fuel cell batteries and everything that were necessary for, I don't know, the Apollo missions or the ISS or, you know, any of the battery systems that are in satellites that are going to be up for a really long time? So that's where a lot of that comes from. And then private industry says, ooh, I like that idea, and then they run with it. Then you've got robotic and or GPS-driven cars. This is the Stanford Car, severely marketed by Red Bull and Intel and Volkswagen and a whole bunch of other things. But, you know, it's a car that completely drives on its own. You know, you just hop in where you want to go, and it does its thing. You know, is that ready yet for showroom floor? No. Can it be? Yeah. Absolutely. You guys could even end up being the people that works on the technology to make this stuff smaller and more integrated and better. Mobile sidewalks. Now you're like, what does the space industry have to do with mobile sidewalks? Well, why don't we have them outside? Like, seriously, why don't you just have a sidewalk running down that you can just hop on and hop off? One of the primary reasons is materials. Rain, sun, you can't use rubber, you're going to end up cracking, it's going to wear out, you have all these environmental elements. Well, material sciences that go into the space industry, they have to invent or make up advanced materials for these really harsh space environments. Environments that are even more positive and negative on temperature scales and everything else than what you have on Earth. So you could use all of these advanced materials to your benefit in making things like mobile sidewalks. It sounds kind of funny, you know, but wouldn't it be easier to walk to the store or something like that if you had a sidewalk, you just kind of hop on? You could still walk at a normal pace, but you get there a lot faster. Just little simple things that could be done in neighborhoods so people can get around. Maglev train systems. That's where you get into the engineering, aerospace engineers looking at ways. One of the primary things that came from the Maglev train system is the Maglev launcher for rockets. So if you had a 10-mile long track that slowly went up and you had just a cargo payload on it, could you accelerate that thing fast enough and get it to go off? Well, on the Earth, kind of hard to do because you've got a lot of wind and drag and thermal heating issues and things like that you're going to run into. If you go too fast, you just light yourself on fire. But if you did it on the moon, where there's no atmosphere at all, you could definitely do a significant launch off of, say, the moon using a Maglev kind of system. Well, they've kind of parlayed that into Maglev trains, which Japan uses a lot of. It's very popular in Asia. I wish it was more popular in the United States. We seem to be seriously attached to our cars and not so interested in more robust, you know, mass transit systems. But a Maglev train would do a whole lot of good to reducing the carbon footprint. Transportation. This one is theoretical on paper, but is plausible. The issue with this bad boy is cost more than anything else. But basically, it's a 2,000-mile-an-hour train in a vacuum. You just basically, you know, build an infrastructure unit, suck all the air out, and so you want to go from New York to LA in about 3 hours. or so, do it. It's possible. You could even do it underground, or you can do it underwater. This one happens to be talking about what if you were going transatlantic, going from like New York to London. How would you do that in a system like this? You'd be able to make up some serious distance. Talk about making the world a smaller place. And it's no less safe than flying a 750 mile an hour airplane at 40,000 feet, and if you lose both engines, you're toast anyway. So, I mean, people will say 2,000 miles an hour, Jesus Christ, you're going to kill everybody. Well, if you're in an airplane, you're going to kill everybody too. So, I mean, it's not, at some point you're already going fast enough. Going a little bit faster isn't really going to hurt much. Plus you're in a vacuum and all that other stuff. So even if all the systems did die out, all you do is just coast for a really long time. And you can apply manual brakes and things like that. You might totally burn the brakes out, but you're in a vacuum, so nothing's going to catch on fire. There's no oxygen. So even if you were sparking like that, it's going to go and go out anyway. So, and then you would flood the air back into it and be able to rescue everybody. So there's a lot of contingency. Engineers will fix that. Okay, so I'm not too worried about that. And then, of course, we've got communication. Something I'm sure all of you use all the time. You've got your Wi-Fi. You all got your laptops up. Some of you are probably playing that stupid mining game. See? You laugh. You're playing that damn mining game, aren't you? But communication is tremendously important to being able to convey this kind of information globally to an audience that otherwise would not have access to it. It's very important to understand it is our communication, not just talking face-to-face, but going over the internet with videos, lectures, educational systems, blueprints to help other individuals build things and do things around the world that allows us to share technology and make the world a better place. So communication, as facilitated by the space industry, are all those satellites that are in orbit that allow all of this instant global communication at the speed of light. Because that's the target in the long run. In the long run, our goal is to explore not just our home, this rock, but our home, this galaxy. And beyond that, our home, this universe. But you've got to take the proper steps. And so by going to this level, by having a target of, we want to explore the galaxy, does that sound like really, really far off? Yeah. 100 years ago, we weren't flying airplanes. Were we? Not really. Not as we are now. So just think what the next 100 years is going to be like. And then the next 100 years is going to be like. And then look at the exponential growth of technology as it is anyway. We get better and faster, better and faster, better and faster. So this is not really an unrealistic target. We just have to push the science, the engineering, and the technology as it applies to space exploration and development, but also as it applies to home-based systems, communication systems, material sciences, problems that we need to solve on the Earth, problems we need to solve in space. They end up all coming together in one little kumbaya anyway. Because it's not that we should. It's that we must. It's the only way we're really going to grow as a species. It's the only way we're going to end up bettering the living conditions of every man, woman, and child on this planet. Thank you. All right. Questions here in a second. Also, if anybody is interested, I go into a lot more detail and cover other subjects. Shameless self-promotion. I do have 6 copies of my book. It's only $20. So if anybody is interested in that, we can do that towards the end. But anybody have any questions? Yes. All right. Thanks, Dr. Phil.
If we want to build a moon base, but we can't predict when the asteroids are hitting the moon and the moon acts as our shield, how do we keep the base from getting destroyed?
Most of the asteroids hit the dark side or the outside face of the moon because the moon is tidally locked to us, so what we see doesn't get hit as frequently as what's there. Honestly, a moon base, the majority of it would be subterranean or sublunar. I can't say terranean because that's Earth. It would be sublunar. So you would have some kind of facility on the top. You can build shielding for that. The rocks that hit the moon are a lot smaller. You just have to build a really thick shield. But honestly, a lot of it would be sublunar because you do run the risk of it getting hit. Now, statistically, lightning never strikes in the same place twice kind of thing. The odds are that if you build a moon base with a small footprint, the probability of it getting hit is relatively small. So even if you did get hit once, the odds of you getting hit again would be remote. And if it did happen, well, it sucks to be a shareholder in that company. But but that's basically the general idea. A lot of the ideas for a moon base would be sublunar, where you would like dig a tunnel down robotically. And who's familiar with Bigelow Aerospace? All right, they're doing inflatable habitats for orbit. Well, same kind of idea. You dig a hole into the lunar underground, sit this thing in there, and then inflate it up and kind of reinforce it. And then you could shove mooncrete into there, into kind of like a honeycomb. It'd be a honeycomb shell that you've inflated. Shove that in there. Now you have this really solid foundation inside the tunnels, and you just build these big rooms, kind of using that idea. I kind of talk about that a little bit in the detail. So that would be how.
Thanks.
Sure. Anybody else?
Concrete or something else, the building printer?
You can use regular concrete. He has also invented something that's a little bit better, faster, curing, more solid, helps withstand earthquakes and things like that. So he's also doing materials research. But I don't think that's his, I don't know if off the top of my head if that's his forte so much. It might be. And he just thought of this robotic bit to add to it. But those are the things that would be considered in the future development of that system, is what would you make it out of? It can drop rebar and stuff into there too. So you would kind of lay some, drop some rebar, and keep laying it as it goes and kind of build it up that way. So there's ways to reinforce it as the computer builds it. But you can research contour crafting. It's contourcrafting.com. It's got an entire web page on it. It's amazing technology.
So you said you were a system engineer. Can you tell us of some amusing system engineering, say, failures that you had to deal with in the shuttle?
Unfortunately, my job's not that exciting. I know, I wish it was. I don't work at the Kennedy Space Center, so I'm not on the interactive hardware side like that kind of system engineering. Let me think. We really just manage. I'm a glorified database manager right now. It's all the drawings. But I do a lot of research on this other stuff because that job doesn't exactly fulfill me, so I do a lot of other things. I'm trying to think of a failure we've ever had that I was there for, because I came in post the accidents. So I wasn't there for Columbia. I definitely wasn't there for Challenger. I was a kid when Challenger happened. Let me think. If I can think of anything interesting, I'll spit it out of the middle of nowhere, but I can't think of anything right now. Anybody else? Over here?
I wholeheartedly agree that all kinds of basic research, like going to the moon, should be funded. But why should space exploration be funded any more than other kinds of basic research, such as biology or chemistry? Because all kinds of things serendipitously come out with things that help humanity.
No, I wouldn't say that space exploration needs more than any other kind, although I think they should work together more. I think if they actually pooled their funding, you got the biological research and stuff like that, space helps them. Now, they do work together a little bit, but if they could share resources a lot better, that'd be easier. Right now, they're so compartmentalized, they almost can't help each other in that way. So you'd be able to increase the financial pot if you could let them work together in a way that's more beneficial to both of their research paradigms. But they're both, I mean, I'm biased. I'll tell you straight up. I just think space exploration covers a lot. Some research entities cover a very specific point of view, whereas space exploration actually incorporates all of them into one thing. And so that's why I think it would need a little more money if it was going to get some, why it would be more worthy than anything else, because if it had more resource, it could bring those other ones into the fold and do more for them too. Whereas if they had more money, their biological research on the Earth can't really help out anything that's going on in space, but the space can help the biological, so it can trickle down one way, but it doesn't upscale the same way. So that's why. Anyone? All right, cool. Is that good? Oh, wait, they're back there. See, there's always that last person. Wait.
In your talk, you mentioned technological solutions to a number of humanitarian problems.
Yeah.
And in practice, outside of the industrialized world, technological solutions tend to not work that well because they rely on manufacturing infrastructure and people with technical skills to maintain the technology.
Right.
So what's your take on that?
That's where you run into the holistic solution set of not just dropping a high-tech system on their front lawn and saying, have fun with it, but it's also educating them how does it work and giving them a basis. I mean, yeah, of course you got to work on the reading and the writing and stuff like that, but that kind of comes with the whole system. You've got to start somewhere. If you can at least provide a technical solution, say the food idea. Now you've gotten that off the table. Now they're not starving to death. Hooray. So now that they're not worried about that, they can get educated on how does that system work? How do those robots and how does that system give me what I need to live, and kind of give them a basis of that understanding, and end up developing that education throughout, the rest of the system, so that if it does break or malfunction or whatever, they kind of know how it works, and they can maybe troubleshoot it on their own, or if nothing else, they can call or make contact with the manufacturer and say, how this broke and how do I take care of it. But it would also be incumbent upon the manufacturer to not be so worried about the bottom line as like making the most amount of profit possible, but just enough to where they can help those people maintain that for 20 and 30-year runs and work with them, not against them in that respect. We've got to become a little bit more, selfless in that respect.
You had mentioned before how, obviously it's been a while since we first went into space, and people the general public is sort of become apathetic to space exploration, which is probably a large proponent in, why there's funding issues and whatnot. It would seem that sort of making space popular again would be the forefront, in getting that funding back. Is that something that, do you guys have a PR department that you have focusing or something? I mean, because just working on all the technological things and saying these are the great things that we can do, when you have, as you said, people like Starbucks, that's why they spent as much as, the budget on it.
If we had their marketing campaign, would space exploration be a lot better? Is that kind of what you're hitting at? I don't work for NASA, but I know enough NASA people in the system. They actually can't advertise in a way. There's a thing in there, because they're a government entity, they're not allowed to do those kinds of commercials. They're not allowed to promote themselves, which is unfortunate. So it really boils down to us promoting them for them. With all the technology and passion that we have at our fingertips to really push space exploration and development, or just what the space industry does for everyone, there should be no shortage of knowledge among the American population or the general population of the world as to what space really means to them. Would I like to see a bigger, more robust advertising campaign that really shows people what it's all about? Yes, I would love that. It doesn't exist right now, and I think you run into funding issues, and I won't get too much on a political bandwagon, but I think a lot of those people don't know they're from a hole in the ground when it comes to really what the engineering, science, and technology means to the future of this nation and the world in general. It's like they're more focused on next year's election than they are about actually sustaining a long-term program. If you look at the Apollo mission, that was an 8 or a 10-year, by the end of the decade, it'll be done. You look at the asteroid mission that's been proposed, maybe by 2030. Okay, how many presidential cycles are we going to go through between now and 2030? Do you think that idea is going to last? Not when the next president is always trying to retool and rerun, or the next Congress is trying to change it and make it their own. So we have to come up with something that is a lot more hard-hitting under a much shorter time frame, or else we're going to keep cycling wheels, which is why I'm big into commercial space, because they're the ones, the Virgin Galactics and the SpaceXs and the Bigelow Aerospaces are going to be the ones to really follow on with those serious large-scale projects where I think the government is starting to falter. All right. Cool. Well, thank you, everybody. I appreciate it.